So for another example, we want to solve and check the equation x minus 1 quantity over 6 equals 4/3 minus x plus 5 quantity over 15. So here, it's not that terribly different from what we got before, except now that because we have those fractions, the algebra, well, it's a little bit less friendly. And if we want to get rid of all of those fractions, we could try multiplying by 6. That would clear out one part there, and it would clear out another a little bit, but then that 15 would still be a problem. So if we need to get rid of everything, what we have to do is find the least common multiple of those three pieces. Those of you that need a refresher, because it's probably been a little while, the least common multiple, or LCM, if you prefer an abbreviation there. I might accidentally write LCD on occasion. It's a bad habit, but the LCM, in that case, is the smallest number that you can get that shares some collection of things as a factor. So here we need something that has 6, 3, and 15 as a factor. Well, the smallest thing that has 15 as a factor that isn't 15 is 30. And usually when you're trying to find a least common multiple, your best bet is to start with your biggest term and try and see how long it takes to get there. So 30, thankfully 3, 10 gives you 30, and 6 and 5 gives you 30. So in this case, if we want to clear out the rational stuff over there, we want to make our lives a little bit cleaner, a little bit nicer to work with, well, we need our least common multiple, which in this case is 30. And so if we want to get things in terms of that least common multiple that we're stuck with, well, what we can do is just multiply everything by 30 and see what simplifies. So I'm going to take the entire equation that we had before, x minus 1, 6, leave a little bit of a gap there, 4/3, plus, that's a minus, x plus 5, and a 15. And again, the cardinal rule of algebra, if I do it to one side, I have to do it to the other, multiply both sides by 30. And the reason why I multiply both sides by 30 is we can put that 30 into 6 and be left with 5 times x minus 1 over 6. And then over here, we multiply in that 30. 30 and 3 would leave 10 to go with that 4. And minus, using distribution, 30 goes into 15, leaves 2 times x plus 5. And from here, a bad instinct would be to try and clear out all of those things, but if we try and clear out all of those things without doing algebra, first, got rid of that 6, that's the whole point, is getting rid of the 6, excuse me. That should just be an x minus 1. But if we wanted to divide those out to get rid of that stuff, we'd just be back where we started, be an endless loop. Instead, what we're going to do is multiply everything through and then try to simplify from there using mostly addition and subtraction for as long as possible. So 5x, 5, 1, here 10, 4 is 40, and then over there, multiplying the negative 2, you have negative 2x and negative 10. And now we can move on to trying to collect like terms. I'm going to keep the x's on the left, move the constants over to the right. So add a 2x over, 5x plus 2x. Over here, we have 40 along with a negative 10, and then I'm going to add over that 5. So I skipped a small step in there by, let's just write it up here, adding 2x and 5. Over here, I'm also going to add 2x and 5 to make sure I follow the cardinal rule. 5x, 2x, like terms, you got 7x's, 10 coming off of 40 leaves 30, add 5 back in, you get 35, and then from there, standard approach, take this, divide both sides by 7 to get rid of that guy over there, and you are left with x is equal to 5. Let me make sure I'm in the right place in my notes because I don't want to get ahead of myself. From there, when we have x equals 5, we want to be sure, we can plug that back into our original equation. So we would have 5 minus 1 over 6, where 5 minus 1 over 6 ends up being 4/3, or excuse me, 4/6, which is 2/3, and 2/3 is in fact equal to 4/3 minus, this would end up being 5 plus 5 over 15, or if you simplify that down, 2/3. That is to say, 2/3 equals 4/3 minus 2/3. So, our solution set is again just one number, but in this case, it is going to be the single number 5. We're going to include that curly braces notation, and my terrible job drawing a 5 looks more like a delta, but it's supposed to be a 5. Anyway, it's very much the same idea when we have these fractional terms thrown in there as a complicator. Just be careful with the least common multiple. The next thing we're going to look at is what happens if instead of putting numbers underneath x values, we put x values underneath numbers. In which case we get things called rational equations.